Hi. We're going to do a little accumulation practice here. We're working on this particular backside of your worksheet, and I'm going to go through these example problems and hopefully explain to you how I get the answer for each one. All right, the given information for the problem is here. It's also printed on your worksheet. So we're going to start right off with question number 1. We want to find the area of region B. Okay, and we're going to get that answer and box that over here. All right, let's go back to this given here. I'm given the fact that f of negative 7 is 10. I'm going to write that right there where my list of my endpoints and my critical numbers are. F of negative 7 is 10. Region A has an area of 24.5. I'm going to come up here and write 24.5. Region C has an area of 13.7. I'm going to come over here and write 13.7. The integral between negative 7 and positive 3 of this function g of x is a negative 10.8. That's negative 7, positive 3, and the net area here ends up being a negative 10.8. That should make sense to you because we definitely have a lot more of the graph below the x-axis than we do above the x-axis. And any area below the x-axis is represented with a negative integral. Any area above the x-axis is represented with a positive integral. Just for a moment, think about why that is. Recall that the integral itself is the summation of a whole bunch of an infinite number of little teeny tiny sliver of rectangles right there. So when I find the base of this rectangle, that's my delta x. When I find the height of this rectangle, it's given by the original function, and in this case your derivative function, g of x, and this height has a negative value for the y-coordinate. And that's why the summation of all these areas turns out to be a negative answer. However, the area itself of the region is considered positive. It's just the integral between like 3 and 12, because this region with a positive area happens to be below the x-axis, and that means the integral between 3 and 12 would end up being negative. Likewise over here with B. All right, so we have region D with an area of 48.6. I'm going to write 48.6, and I'm going to put a negative sign on it because of its location below the x-axis. All right, now I want the region B's area. The answer to this I want to be positive because no matter where the region is, we say its area is always positive. We say its integral is positive if the region is above the x-axis, and the integral is negative if the region is below the x-axis. So this integral is definitely going to be a negative answer, but the area of region B is going to be a positive answer. So, how can I find this region if I'm given all of this information? The integral between negative 7 and positive 3 is given as negative 10.8, and I know one of the regions, I don't know the other one. So this is going to be a part plus part, or I'm going to call this a change plus the change is equal to the total change between negative 7 and 3. And that's what I'm going to work on. I'm going to say change plus change equals total change. I've also said part plus part equals whole, and that's true too. Same idea, except the word change indicates to us that we're dealing with an integral, so I want to use the word change. So I'm looking at the integral from negative 7 to where it breaks and the function goes up into region C, so negative 2 of g of x dx, plus the region from the negative 2 that I left off on all the way to the end of region C, which is a 3 of g of x dx, gives me the overall whole region from beginning to end, beginning at negative 7, ending at positive 3 of g of x dx. Now I can replace g of x with f prime if I feel like it. And I think throughout this whole ordeal, I think I'm going to go back and forth a little bit just for something to do. Okay, between negative 7 and negative 2, that's kind of the thing I'm looking for. I know it's going to end up being negative, and I'm going to have to give the positive value of that for my area. But the rest of this I know automatically. This is a 13.7, and this was given as a negative 10.8. So this is still the region, or the integral between negative 7 and negative 2 of g of x dx. So I'm going to subtract 13.7 from both sides of the equation. And I end up with the integral between -7 and -2 of g of x dx as equaling a negative. When the negative makes a bigger negative, what's this? 24.5. So the area of region B is actually 24.5. I'm not going to say -24.5, that's what the integral is, but the area of the region itself is the positive 24.5. Now I'm going to come over here and I'm going to put positive 24.5, but then I am going to throw a negative sign on it because the region itself is definitely below the x-axis. So therefore the summation of all those rectangles that have a height value that's negative, kind of weird but true, okay, is going to give us a negative accumulation of area here. Okay, question 1 is done. We end up with a negative 24.5 for the integral, but a positive 24.5 for the answer to the question, which is the area of the region. Question 2 says, what is the integral between -2 and 12 of g of x dx? -2 all the way to 12. So if I were to add up all these rectangles and all these rectangles and come down here and all these rectangles that are beneath the x-axis here, what would my overall sum of all those areas be between a -2 and a positive 12? I know the answer is going to be negative because I got a lot more negative than I do positive. So I'm going to put these together. But basically, the idea here is that I'm looking at change plus change equals total change again. So I'm going from -2, that brings me on my left bound over here, all the way to 3 of g of x dx, plus, where did I leave off? I left off on the 3, so that's where I must begin again, all the way to my end limit there, which is my 12 of g of x dx. Gives me the whole entire total change from -2 all the way to 12 of g of x dx, which this right here is my question. That's nice. All I have to do is put these down and add them up. This integral is a 13.7. This integral is a -48.6. The negative is because the integral takes into consideration the placement of the region. And that's going to be my answer, whatever that is. I have overall negative. If I take 13.7, which is positive, put it together with a -48.6, I'm looking at something 0.9. Let me see, 4054, 34.9 for this overall region between -2 and 12 of g of x dx. So -34.9. So if the function f had a particular value, which I'm sure it does, at -2, then that function of f increases 13.7 to get to x equals 3, and then decreases 48.6 to get to f of 12. Okay? Or if you think about it, just going from f of -2 to f of 12, the graph of f would decrease by 34.9 overall. Even though it went up and went down, its net result would be going down 34.9. Okay. So much for 2. Question 3 is looking at the integral between -12 and 12 of the absolute value of g of x dx. So I need to add up absolute values. Absolute values are always positive, so I need to add up a bunch of positives. Think about what the absolute value of g of x represents. The absolute value function leaves positive values alone, so here my g of x function is positive, it's going to be left alone. But the absolute value function will take negative values and make them positive. So this graph section right here basically is just going to reflect up above the x-axis. And I don't know if I drew that, properly or not, but the idea is the -24.5 area down here, the region, is going to come up here and become positive 24.5. 13.7 is already above the x-axis, it's going to stay where it is. And then this negative region of g of x is going to become positive. It's going to go up here like this and come back down. So the negative 48.6 won't be down here anymore. It'll be up here as a positive 48.6. So I end up taking a 24.5, adding another 24.5, adding a 13.7, and then adding a 48.6. This overall sum, if I put these things together, is 111.3. And that is the answer. Oops, 111.3 would be the answer to that problem. Alrighty. I can't go on without just mentioning to you that the integral between negative 12 and 12 of the absolute value of g of x with respect to x is not the same as the absolute value of the integral between negative 12 and 12 of g of x dx, like this. These are two completely different things. They look different. The absolute value here is containing the g of x, and the absolute value here is containing the integral between negative 12 and 12 of g of x. This idea would mean that you would take the 24.5 and plus a negative 24.5, and then plus a positive 13.7, and then plus a negative 48.6. And you would add all of these together to get your overall accumulation, and then absolute value that. This takes into consideration I have some negatives, and it has some counteraction moving before I absolute value. This absolute values my pieces first, and then adds up a whole bunch of positives. They are completely different questions, and they mean different things. So we are going to stop right there for right now, okay?